What's up, guys? Wanted to film a quick video to kind of give you an idea of what we're talking about today with the explicit and recursive sequences, how to write a formula for them, and how to find like future terms. And so let's just jump into it. This first one is subtracting 10, which I already had written. And so I want to write both an explicit formula, which helps me plug in like some future term, like if I'm wanting to plug in 10 or something, and then also how to write it recursively, which means like how does it build on itself. So looking back at what we did in class today on the front, where you kind of figure out the second term minus the first term, that's your slope, and then figuring out like what number would have been even in front of that first number, like going back not to the first number, like the 0th number. That's kind of tapping into your understanding of y-intercept, hopefully. So because this is going down 10, that is that 16 minus 26, that second number minus the first number. And then I can also see that this number would have been like 36 if I had said, okay, what number is really in front of that? That means that your y-intercept is really starting at 36. The first time you subtract 10, it lands on 36 perfectly. And again, that's because 26 is the first number, which means when you plug in 1, the formula has to work, meaning it has to give you 26. And it does here. Negative 10 times 1, negative 10, plus 36, 26, it works perfectly. And it works for all the other ones as well. So now, if I wanted to build one that was recursive, I want to think about that based on really more like how to write it based on the previous term. So the way this is working is you take the number before it and subtract 10. 16 minus 10, 6. So if I want 6, you take the previous term, subtract 10. So this is really more about getting used to writing it in probably a new way. So this means the future term, like the nth term. And so if I want to talk about the 10th term, this would be the 9th term. And so if this is n minus 1, 10, 10 minus 1, 9. So no matter what n is, it's always 1 right before it if you subtract 1. And so that notation really means like the previous term. And of course, you're taking every previous term and subtracting 10. And so that is the answer for the recursive formula part of number 26. So like I was saying, if you want to plug in a number, we need to plug in 10 to this one, because to do this one, you really need to know like all the terms. You need to know the first term, and then the second term, and the third term. That way you know like the previous term, the 9th term, minus 10, what that 10th term is. So the explicit's way faster for a lot of computations. So negative 10 times 10 is negative 100. Okay. And then let's add 36 to it, and that's where we get negative 64. So that is the answer to the last part of that question. Okay, so let's do one more together, and we'll let you do 28 on your own. So this is where we're going to start with thinking about what is the first term. First term is 200, so that's not too bad. And then you got to think, what is happening in the pattern? Well, 100 divided by 200 will help us understand that this is actually halving. If you're thinking about division of 2, that's good, but we need to write it where it's more like a fraction. And like we said today, dividing by 2 and multiplying by half are the same thing. So we just throw an n minus 1 as the power, and that's what allows us to put 200 here. If you notice, we went back in time on the first one, and technically you could do that as well. We could go back in time and say, okay, that's really 400 as the first term, and it's multiplying by half. But then we would just say it's to the nth power. We wouldn't subtract 1. And it's all about how do you get that first number to be 200. So for example, when I plug in 1 here, I'm going to be taking 400 divided by 2, or I'm halving 400 one time, and I'm going to get that 200 immediately. Okay, or if I'm plugging it into here, you're plugging in 1, and when you plug in 1 here, 1 minus 1, 0. When you raise something to the 0 power, it makes it 1, unless it's 0. That's undefined. But for all of the numbers, it makes it 1, and then 200 times 1 is 200. So really, it just depends on how you want to write it. Honestly, they're both correct. You could learn either method, but I think this one is the easier one to do. All right, so the last thing we got to do, well, not the last thing, the next thing we got to do is we got to write this geometrically, which means we're basing it on the previous term. So just like we set up here, we're taking half, that's the ratio, and we're halving whatever that previous term is. Okay, that's how that works. So again, if we're going to plug 10 into something, I think I'd rather plug 10 into this one because it's going to make it a little easier to calculate. So let's use my graphing calculator here. 200 times 1/2. We're going to raise that to the 10th. Okay? So that's one way we could do it. That gives me 0.39. So I'm going to press math enter to see what that value is. 25/64. So that is going to be your next value, or your 10th value rather. So you do 28. Tell me how you feel about that tomorrow in class. And then, of course, we talked a little bit about this one right before class ended. I'm reading through this. Basically, the first day, you have a $300 penalty for not finishing a job on time, basically like a construction job or anything that has to do with like a contract. And then we also have that increasing $500 on the second day, $700 on the third day. So let's try to write an explicit formula for that describes basically a way to calculate based on any number of days. If I want to say, well, I'm 10 days late or I'm 12 days late, how could I just plug in the number and calculate that super quickly? And then if you knew the outcome was going to be 4,500, how could you basically reverse this concept to figure out when that penalty is going to be $4,500? Okay, so that one's probably going to need to think recursively a little bit. So I want you to think about that, and we'll talk about it tomorrow, and see you then.